Hey everyone, it's Mrs. Slauson. So you're not going to see me in this video. It's Sunday. I'm in my pajamas. I've got 3 dogs on their beds in front of the fireplace and other people in the house. So I might be pausing in case there's an interruption, specifically a dog or 3 barking. Anyway, let's go ahead and get started. So in week 9, the remote learning part, we are going to be reviewing how to find equivalent forms, which is what we did right before we went on break. Technically, this is all review because it was in Algebra 1 and the fact that we've already covered this. But this section is so important. You have to know how to do all of these things in order to make it through all the other chapters of Algebra 2. So please, please, please follow along the video. It's going to be kind of a section of we do the left side and then you do the right side. So what I encourage you to do is, as you are watching the video, once we're done with the problem on the left, pause the video and do the problem on the right. Okay? And some things for some of the groups maybe will be a little newer than another group. It just depends if you are in the red or silver group. And then when you're done, you will be turning this in. You can submit it to me and bring it to me in class, or you can go to OneNote in the Chapter 2 folder, and it will see exactly as titled as the top, Week 9 Remote Learning Practice. And you can print this out and submit that, or just put your work on a different piece of paper. Okay? All right, let's get started. So here we go. In the first section, we are going to talk about how do you go from factored form to vertex form. So just a little reminder on this, vertex form, they both have parentheses, but vertex form, which is what these two are, has parentheses squared, whereas factored form has no squared. It's just the parentheses. Okay, so just a little heads up on that. All right, either way, what we're going to do is get these so that there are no parentheses, and instead there's just terms. So the pieces that are separated by addition and subtraction signs. So basically, this is where we do a lot of distributing and what I have nicknamed as the neighbors meet the neighbors. So we've got one neighbor here and another neighbor here, and x is going to go over and meet the neighbors first. And we are multiplying, so x and 2x when you multiply give you 2x squared. And then when the x meets the 7, as I'm redrawing, I get a positive 7x, so I put plus 7x. And now when the neighbors meet the neighbors, it's time for negative 4 to go meet. So negative 4 will meet 2x, and I get a negative 8x, which I'll have to combine with the 7x term. So I'm going to stack those like terms. And then this minus 4 or negative 4 will meet the 7, and that'll be a negative 28, or you could do minus 28, whichever you prefer. And I'm just going to add this up, and I get 2x squared. Negative 1x, you could do minus x minus 1x, and then plus negative 28. The subtraction versus adding a negative, that's totally up to you. So when we're done, this is our final answer. So what I would suggest you do now is pause the video and do the one on the right. All right, so the next problem, again, as I already told you, this is in vertex form, and we are going to go from vertex form into standard form as well. So no parentheses. And what I want to do is acknowledge that this negative is, if you'd rather have it as a negative 1 in front, and that the squared that you're seeing means that there are 2 of these x plus 1s. And then we got this minus 8 kind of hanging out on the side. So as far as the neighbors go, we have 3 neighbors, and I'm underlining all of them. And you can only have 2 sets of neighbors meet at once. So what I would always suggest you do is you have the parentheses meet first. So what I'm going to start is x is going to go meet the neighbors first, and I'm going to get an x squared and a 1x. And then the 1 is now going to go meet the neighbors. So I get another 1x, which I'll have to combine with the first 1x. And then when I multiply the 1 and the 1, I get 1. It's not 2. And I'm going to add these up, combine my like terms. And so far, we have 2 of the neighbors meeting. So these neighbors are gone, and they're this new group that you see in blue. But there's still a 3rd neighbor who needs to meet, and that's the negative 1. So I'll put him in front, or her, and just distribute through. and I'm running out of room. That's okay. So now I'll have negative 1x squared, which usually they wouldn't put the negative 1, but I'm going to put it there. Negative 2x, and again, when I multiply negative 1 and 1, don't add them, I get negative 1. So now all of the neighbors have met, and what I don't want to forget about is this minus 8, who is just going to combine with a like term of negative 1, and when I'm done, my final answer, which will be in this blue, will be negative 1x squared plus negative 2x. You could also do minus 2x. And then when I combine negative 1 and then I take away 8 more, I get negative 9. Or in this case, I'll put minus 9. So this is my final answer. So again, what I would suggest you do is pause and you do the problem on the right. All right, now we are going to go from standard form to vertex form. So again, these two problems in the bottom here were vertex form. They are when you have a parentheses squared. So this whole process is, again, called completing the square when we do that. And what I talked about is we're going to kind of group this up. We're going to group our x's together. And when I do that, I put them in parentheses. And we are going to be completing the square. So what I'm going to be doing is we're going to be finding a term to add to this, and I'm going to put it in a square so I remember that this is called completing the square. And then this minus 2, it does not have an x with it, so it is not going to be grouped with the x's. And then again, what I'm going to do is put minus a box. And I'll explain again, as I have before, why there's a plus a box and minus a box. So the number that has to do all the work in here is this 8. You always take this number, leave the x off. And when it's a number right in front of a variable, the 8 is called the coefficient. So you always take that coefficient, that number, and you divide it by 2. And then you take that number and you square it. And I would always suggest you do this in your head, because remember, 4 squared means 4 times 4. And that's 16, and the 16 is going in this box. So what we're doing is we're creating an equivalent form. So what I want is something, I'm creating an equation that's equivalent to this. It's worth the same amount. And right now, it looks very much the same, but I have this plus 16, so it's actually not equivalent. It's not worth the same because I have an extra 16. So to keep it the same, I'm going to have to go to my other box, and since I've added 16, I'm going to take away the 16, and what happens is these 16s technically cancel each other out. But now we're ready to finish the problem. So where I always start is the stuff outside of the parentheses. I think of this just as a little math problem, like a negative 2 subtracting 16, and that's negative 18 or minus 18. And then I'm going to make my parentheses squared. That's part of vertex form, and it's always going to be x plus. And now we got to get that number. And the reason why I want you to show all this work over here in this blue is because the number in front of this squared is the number that will go in front of this squared. And now we have the equivalent version of x squared plus 8x minus 2. It's just in vertex form. So what I would suggest you do on the right side is the f of x. And that shouldn't be a plus minus. Sorry, I didn't realize that. Your version that will be available for you will just have actually a minus sign. So if you're printing it up, that correction will be made. I didn't realize that happened. So it's x squared minus 6x plus 1. So you should do that one. And then I'll be doing the next one. And the next one you definitely want to watch because there's a catch to it. All right, in our next problem, completing the square, you're going to, again, group these x's. So I put them in parentheses first. And I'll be completing the square, so I put a square in here. And the 1 doesn't have an x with it, so it does not go in the parentheses. And now I'll subtract a square. And in order to complete the square, this leading term, this one that starts it all out, has to be just x squared. So what I'm going to do is a GCF of what's in the parentheses. I will be factoring this out so that it's just an x squared here, which means I'll technically be factoring out like a negative 1, which means I'm going to factor a negative 1 out of this and out of this. So this becomes a plus negative 6x. Okay? And if you notice, it's going to be really similar to the problem that you're doing up in the right, but a little different. All right, so anyway, here's the rest, the box. So again, what I'm going to do is take this number does all the work, It's -6. I'm going to cut it in half. That's -3, and I'm going to square it, which again, just do this in your head. Don't use your calculator because you might not type it in correctly. -3 squared means -3 times -3, which is 9. So the 9 goes in the box. And normally I would put 9 in this other box, which I didn't put a box. I put a blank. But what you have to realize is even though we wrote 9 down, it's actually not worth 9 because this -1 affects everything in here. So if you distribute that back in, that's a -x squared, you have a -6x, but even though we wrote 9 down, when this -1 reaches this 9, it's actually worth a -9. So technically, I didn't add 9 into my problem, I added a -9. So since I added a -9, then in this box, I'll want to subtract a -9 to keep these equivalent. And now I'll start with cleaning this up. So again, I start just outside. I think if this is 1, take away -9, which is the same as 1 adding 9. You can add the opposite, and that becomes 10. And then I'll make my parentheses, squared. And again, it's always x plus, and whatever is in front of this squared, which is a -3, will be in front of the squared, so -3. And then the other thing I want to consider is this -1 that's sitting out in front of the parentheses, because it will just go here out in front of the parentheses. And this is my final answer. So when you do the one on the right, it's definitely going to be a bit more of a challenge. All right? Okay, so that is standard form to vertex form. This whole process is completing the square. The final part, yes, there are quite a few, and I do apologize for this, but this of all of it is one of the most important parts, is how do you go from standard form, so no parentheses, to parentheses. And we made this little chart in our notes, and the very first step, I'll make a little bit of room here, is you always look at everything and you look to see, can I factor out a GCF, a greatest common factor? So what I do is I look at every term and see what I can factor out. And for instance, on this first one, you're going to notice that it starts out with a -5. You always want that leading term to be positive. So if you see a negative there, you're guaranteed that you will have to factor out at least a -1. In this case, when I look at both terms, I can factor out a -5. And when I look, they both have x's, and I can factor out at least 1x from both terms. And factoring is just undistributing. We're finding out who the neighbors were that met to get -5x squared minus 45x. So I'm going to factor out a -5x. And when I do that with this first term, I'm just left with an x. And when I factor a -5 out of the other term, then I'm left with a +9. So again, what should happen is these are the neighbors who meet to give me this term, and this neighbor meets this to give me this term. So what you're going to do is the one on the right. Again, I'd suggest you pause the video, do the one on the right. Next one. So again, the first time I always do this, I'm going to look for a GCF, which I do notice it does have a 2 that I can factor at every term. So I'm going to do that first. So when I divide or factor out a 2 from every term, I'm left with x squared, I'm left with a 5x, and I'm left with a 6. So now what we're going to do is, after the GCF, is since we have 3 terms, we're going to do what we call the x. And what you have to do is make sure you multiply the first term and the last term, and that goes in the top. And then you take the middle term and put it in the bottom. And then you can run this factor program that I put on one group. The red group got the factor program. The green group, you got this green factor page. Well, all the groups got the green factor page. That you need to find factors of 6, numbers that multiply to 6 that get you to 5 if you add them up. So these are the factors of 6, not that many. And I want to see which ones, whether I add or subtract them, get me to 5. And as it turns out, they both do. But only this set will work. Because if I put 2 in here and you put it with an x and a 3x, when I multiply these terms, I get what's at the top. And when I add these terms, I get what's at the bottom. And so we're going to go straight into our parentheses. So again, we're just finding out who the neighbors were that met. that got us to 2x squared plus 10x plus 12. And the part that we're factoring right now that's going to go in the parentheses is the x squared plus 5x plus 6. So it's always, who met who to get this x squared? Well, that's just going to be an x and an x. And now what I'm going to do is draw these loops. And these loops will help me figure out these two terms. So for instance, I want to ask myself, I'm going to use the highlighter, x times what can get me to 2x? And that would just be a 2. So I can do a 2 and I'll put a plus 2 for a positive 2, and that gets me the 2x. And then I'll ask myself, x times what can get me this 3x? And that would just be a 3, so plus 3 for positive 3, and that gets me my 3x. And now I factored that, and I don't want to forget about my GCF for my final answer. So these are all the neighbors who met to get me what's on above the original problem, the 2x squared plus 10x plus 12. So now what you're going to do is the next problem. Again, look for a GCF and then make your x. So again, I'd suggest you pause your video and go from there. In the next problem, again, what I'll be doing is looking for a GCF. There is not anything I can see that can factor out of all three terms. So I'm just going to go straight to my x. And again, I'm going to multiply those. So that's negative 24x squared. And the middle is going to go on the bottom. And I'm going to look for all my factors of 24. So I'll write them over here. Again, factor program, or you can use your factor page, but which of these sets, whether I add or subtract them, would get me to 5 or negative 5? And the only way that will happen is with 3 and 8. So I'll be putting 3x and 5x in here, and I'm sorry, 8x. And I'll have to make the 8 a negative to get to the negative 5x. So I'm going to erase these factors. And now we're ready to make our parentheses. Who are the neighbors that met? That gave me 2x squared minus 5x minus 12. So first I want to see who are the neighbors that met that made 2x squared, and that would be a 2x and an x. It's going to be very simple. And after that, now I'm going to draw these little loops. And I'm going to ask myself first, I'm going to try for the 3x. So is there 2x times something that can get me 3x? And there's not, so that won't work. But is there 2x times something that can get me to negative 8x? And there is. A negative 4 would make a negative 8x. So, and then since the negative 8x has been done, now what I'm going to use is x times what can get me the 3x over here. And that would be a positive 3. So I will do plus 3. And now if 2x goes to meet everybody and 3 goes to meet everybody, you'd get the 2x squared minus 5x minus 12. So let me just show you that. So in a different color though. So if 2x meets x, there's 2x squared. When 2x meets the negative 4, you get a negative 8x. Then 3 goes to meet and you get a 3x, and 3 goes to meet the negative 4 and you get the negative 12. And then when you clean this up, simplify it, you get what we started with. Okay, so anyway, I would suggest you pause and you do the problem on the right, and then the problem last two. Okay, so on the bottom two, I'm going to do this erasing so I have a little bit more to work with. So again, the first time I ever try to factor, I want to look for a GCF. And again, I always want this term to be positive, so if I have to factor out a negative, I'll do that. So I'm going to notice I can factor a negative 2 out of everything, and then I can also factor an x out of both terms. So when I do that, I'm left with an x squared and then minus 25. So since I'm not left with 3 terms, then we have to remember that there's this option of 2 terms. That's that whole difference of squares. And again, this is in your notes in that second section, 2.2. And this qualifies as a difference of squares. Again, this is what we're trying to factor. It's called a difference of squares because we have the subtraction, that makes the difference. And then squares because these both have nice square roots. And so joining the negative 2x in my factors, I'll go straight to my parentheses or my neighbors, and I'll take the square root of x squared, which is just an x. I'll take the square root of 25, which is a 5. and they will go in here, and one will be x plus 5 and the other will be x minus 5. And then these are the factors or the neighbors who meet to give us this. So you're going to do the problem on the right. When you're done, you will be going into your, you can turn this in, or you can go to Schoology and look for the title in the section 2 folder. Look for this title there, or here it is again, and take a picture and submit it. All right, that's it.